Hi, good morning to everybody. It's a great privilege and honor to be presenting today. It's going to be myself, Dr. Alan Barnard. I'm CEO of Goldratt Research Labs, and our VP of Simulation, Jacobin Vosloo. So we'll start off with just a quick introduction of our company. And after that, we'll do an introduction of this very, very inspirational client that we've built the model for. We'll provide some background to the client and also background to the actual project itself, the model objectives. I will then hand over to Jacobin, who will describe the model design in detail, share with you the reason why we use simulation and specifically AnyLogic for this very exciting project. Jacobin will then do a model demo, and we'll end off with, after the model demo, which will show the scenario setup, the single run sensitivity analysis, and also a very exciting future of essentially using ChatGPT inside of the model. I'll end off the presentation with a summary of the results. So ready to start, just an introduction quickly of Goldratt Research Labs. It is a company that I co-founded in 2009 with Dr. Eli Goldratt, who's the creator of Theory of Constraints. The objective, the vision of our company is to help both organizations and individuals make better, faster decisions when it really matters. And often that boils down to starting with two simple questions that we help them answer. How much better can you do, or a lot? And normally it is a lot. And secondly, how best to do much better in the simplest, fastest, lowest cost, lowest risk way. And that is where simulation plays a big impact, because we can do all sorts of hypothesis testing about the consequences, the causes, the cures of certain problems that they are experiencing, all within a virtual environment that offers very low cost, very low risk way of testing any hypothesis. We've been privileged over the years to work with some incredible companies. We've worked with Microsoft. We presented that case study a few years ago at the AnyLogic Conference, and also case studies for Tata Steel and ABB and BHP, Cisco Systems, etc. And we are also very privileged to work with some exciting research partners along the way. So we'll going off to the specific client background. As I mentioned, this is a very exciting project for us. It's an inspirational company, Z-Life company. It's owned by two women. It is based in Las Vegas, the same town that I now live in after immigrating to the US from South Africa. And Z-Life offers cutting-edge real estate development, both in structural design and modern living experience. They actually started with a system that they've developed called the Matrix system, which they use to design the glass wraparounds and put glass wraparounds around high rises like the Salesforce Tower in San Francisco and the Fontainebleau in Las Vegas. Jacobin, if you can advance the slides, thank you, all the way to the bottom. They really are aiming to revolutionize this industry. There's a major problem in most inner cities where there's a housing crisis. There are stock available, but it's often unaffordable for the type of middle-class people that want to experience inner city living. And what they have done is they have studied what makes up most of the costs for middle-class families and young people. And essentially, accommodation cost is by far one of the biggest ones. So what they did was they moved from high rises and realized that this innovation they came up with, which essentially combines the best of pre-design, pre-engineering, pre-manufacturing with modern style building materials, to be able to build luxury low-rise apartments and boutique hotels, like the first project that they did with the English Hotel in Las Vegas, in about 30% less time and 30% less cost. I was very privileged to have been invited to serve on the advisory board. And one of the questions that Weena Chang, the founder of Z-Life, said is, are there any other ways that we can help these middle-class families? The second biggest cost by far for these families and young people are transportation. And she came up with this brilliant idea that said, Jacobin, if you can move over to the next slide, if you could it be possible that you find a way that there's a major win for not just residents and developers, but also the city council. So the idea would be, could you come up with a solution for these low-rise apartment buildings and boutique hotels where it substantially reduces the transportation cost per month for residents, but it also solves two big problems for the developers and the city council, which is it reduces the amount of parking bays that is needed. This is a huge cost to both developers and to the city council. So that's how the idea came about, is to say, what if we benefit from aggregation? There's already a lot of shared services inside of these low-rise apartment buildings where people can share services, so you can get access to an asset without having to own it. But what about including in that cars? And that was, if Jacobin, if you can advance, please, to the bottom right. What if you could offer to the residents this option where if you are willing to give up your car, you can get free access to a Tesla. And depending on the size of the apartment that you have, there are studios, there are 1 bedroom, 2 bedroom, you could get access for up to 2 hours per day to a free Tesla. Most of the people living in these inner city areas can walk to work, or they can take public transportation, or even use scooters, etc. So most of the time they need a car not to go to work and back, but for other usages like dropping off kids, or maybe going to shopping, etc., going for a long weekend. And that was her idea, her original idea. And she asked me, she said, if she did the basic calculations or the static calculation using averages and a typical driving pattern and schedule of a typical family, she gets that they will need about 50 Teslas for every 250 apartments to provide reasonable waiting times. I helped her specify exactly what it is that she was looking for. She said she didn't want residents to wait more than 5 minutes on average for Tesla. Of course, in some cases, you can imagine that it might be longer. And as a result of that, is if she wanted to provide a full solution, she said, well, what if we supplement the free-to-use Teslas with also pay-to-use Teslas, which is providing two opportunities. One is that residents that want a Tesla, but there's no free-to-use Tesla available at that moment, it might be too long waiting time, they can decide to use one of the pay-to-use Teslas, and at a fraction of the normal cost of renting a car, maybe $10 an hour, they can use the Tesla. And those pay-to-use Teslas that are not being utilized by residents can then be rented out to non-residents to provide some additional income for the developer. So that's how the idea started. It's a very, very innovative idea. It got a lot of press, including the fact that the simulation is the best technology to answer the question about whether this is even viable, and will it really be a win-win-win for the residents, for the developers, for the city council. So I started working with my team, Jacobin, to build this model, and the specific objectives that we had was how many Teslas, free-to-use Teslas, are really going to be required for an apartment building that has 250 apartments. What will be the average waiting time? And if we wanted to make the average waiting time reasonable, like less than 5 minutes, how many additional Teslas do we need? And then since the people that would be using the model are not necessarily technically capable of doing the parameter adjustments and analyzing the data over a long period of time, because this model will be expanded not just to be used for the first apartment building, but for all apartment buildings that they're planning in the future, starting in Las Vegas, where they have already bought out a number of properties, but then expanding it over to other inner cities like San Francisco, Austin, etc. So I'll hand over now to Jacobin to talk a little bit about the specific model design and to provide a demo.
Thank you, Alan. So a little bit more detail about the setup of the model and how everything fits together. We've got two different Tesla fleets. So the first one is our free-to-use Teslas, which is reserved solely for the use by the residents inside the apartment building, and when they've got 3 minutes available for use on the Teslas. The second fleet is the pay-to-use fleet. Now, this fleet can be used by residents who've used up all their free minutes, or by non-residents that want to make use of the Teslas, right? So a normal pay-per-use system. And this is our entire Tesla fleet. Now, the one thing is that these Teslas require parking space. And as Alan mentioned, it is a big driver for the city, for the council, and for developers to use as little parking space as possible. Hence, we're trying to ask residents to give up their parking spaces so that we can aggregate this resource and say, let's all share this. We share the vehicles that's parked there as well as the parking space. Now, in the apartment complex, for the models that we've been working on now, there's about 250 apartments, but they're all different kinds of apartments. So in the model, you're able to specify between these three apartment types that we've made provision for: a studio, 1 bedroom, and a 2-bedroom. And you can specify the fraction of apartments for each type, as well as the free minutes that they get per day. Now, these free-to-use minutes now accumulate either on a rolling or on a fixed number of weeks, and this is one of the things that the developer is still testing out. So it's either you get 12 weeks to use it, and then it resets and you get another 12 weeks to use it, or it just starts building up from 0 all the way until 12 weeks, and then it's like a rolling 12-week window where all your previous days, minutes accumulate, and so the last 12 weeks days falls off at the end. Now, inside the apartment or inside the model, we've got residents that live inside the apartments, and we've got non-residents. Now, these residents and non-residents are different kinds of agents, and there's a specific fraction to which we've programmed them, which you can obviously change. And then there's an active period. And this is not the period that the resource is actually, or the person is actually active working. This is the period at which they're active and they're most likely to use their car because they're not at work, right? They're going to the shopping mall, they're going to do something. So for example, for the night workers, between 10 a.m. in the morning and 5 p.m. in the afternoon, that's the most probable time that they will be using the vehicles. Day workers then from the afternoon until the evening, and entrepreneurs throughout the day, as well as out-of-state residents, which is the residents that typically only get there on weekends, use the apartments on weekends. So one other slight complication is that some of the parking space needs to be used for residents that do not want to give up their parking spaces. So there's additional 50 parking spaces that we need. That's sort of just a cost to the developer, and that's kind of ignored for the rest of the simulation. Now, non-residents and residents with no free use left can use the pay-to-use Teslas. Now, non-residents pay a higher rate than residents, so this is purely like income for the developer. But the non-residents pay a higher rate, and so the residents actually pay a rate for the use of their pay-to-use Teslas. And the idea here is that we wanted to see, as Alan mentioned, whether we can save residents the money that they would have paid had they owned their own vehicle by giving up their parking space, giving up their vehicle, getting 3 minutes on their free-to-use Tesla, and then paying a small portion on when they've ran out of 3 minutes. And that quantity must be less than the cost of owning your own vehicle. So the Tesla usage cycle, which we did, Teslas are just agents, so they're parked, then a resident can use it or a non-resident, then they get inspected, cleaned, and charged again. There's specific durations for these based on the trip that the Tesla took. We just differentiated between short and a long trip. A long trip can last multiple days, and short trips can be anything from an hour up to, I think, 16 hours or something. So, and based on these, there's a different charging time and a different cleaning and inspection time for each one of the Teslas. So why simulation and why AnyLogic? So the first one on why simulation, it's actually very simple. There's no way you can do this calculation of how many Teslas do you need in any static calculations or any Excel spreadsheet. And only simulations you can model these behaviors of the agents, right? The cars are pretty fixed, and the agent's behavior you need to specify based on the types in the apartments, etc. And so you need to consider all of these interdependencies and the constraints and the complexities and all the variability, because it's all probability based whether or not they're going to use a Tesla, whether or not it's going to be a short or a long trip. And with our sensitivity analysis, as we do with all projects, we can provide a range of likely outcomes for a single scenario, and we can do direct scenario comparisons, etc. So for this specific one, we had to do sensitivities on the number of the free-to-use Teslas and pay-to-use Teslas, with variations on some of the other parameters like the 3-minute expiration, whether it's rolling or a fixed period. So a simulation can provide a low-risk, low-cost way to test the impact of any changes. You can imagine in something like this, if you make the wrong decision and you build too big a parking lot, you've wasted a considerable amount of capital. Or even if you build a too small parking facility and now you've got residents that actually don't want to participate in this program. So it is absolutely crucial that you make sure you've got a low-risk, low-cost way of making sure you're making the best decision with the information available. So why AnyLogic? As always, it can replicate real-world complexity using both agent-based and discrete event simulation methods. So what's nice here is that the agents that we model are completely interdependent, and then they interact with vehicles, and the vehicles go their separate way, and then the vehicles follow a discrete event flow in order to get back into the parking state where residents can use them again. The ability to create self-configurable models that really cuts your development time. It ensures usability and scalability for a range of system configurations. So most of the things in this model are data-driven. So based on the user settings, we create more or less of any given agent and define different apartment types and new Tesla states, etc. It's quite easy to change. The ability to export the model as a standalone app, as always, because this specific application is going to be used by the developers themselves to do all their planning and tests, etc. So we need this to be in the hands of the developer. And then the ability to run it on AnyLogic Cloud, especially if you've got resource-intensive models. So the ability to utilize standard Java libraries and integrate with numerous other applications. So in this model, we actually tried our hand at integrating with a ChatGPT assistant, which you'll see in the demo video just now, similar to the one built by Nerdjax. So we were able to completely integrate with the ChatGPT assistant through just standard Java and web API libraries that's available in Java. So this makes it really easy to integrate AnyLogic with pretty much any standard tool out there. Okay, so a quick model demo. So as we mentioned in the objectives, is the model had to be completely configurable from the UI. So unlike our previous models where everything is always imported from Excel, everything here needed to be on the UI. So we need to make it as clear as possible, as simple as possible. We've got our setup page in the beginning there for residents. This one is for the Teslas and the residents' usage probabilities. As you can see, everything is editable and you can change it in the UI. See the impact of some of the changes that you make on financials. Here on the next page, this is our static financial plan. And you can still save all of this information. And because the customer didn't need to make changes in Excel, we just created a little, or used a standard library to create a JSON object. So you can download it, share it with other users, save it as the default as well, load the default, load a previous JSON object. So it's very, very simple to use. So for this part of the demo, we're going to go into a single run. A single run, we've got the summary view with some basic information, which we're going to get back now. On this detailed view here at the top, we show the day type, whether it's a weekend or a weekday or a holiday. And this informs you, helps you stay informed about what is the steps here below, because there's different utilizations over weekends and weekdays. We can see the utilization of our Teslas. Here it's called overflow Teslas. That's what the paid Teslas is referred to. The resident status, whether they want to be driving or not. They're taking short trips or long trips. Let me just get back to that video. Got it. You can see the hours available for the resident as it is accumulating here because it's the start of the model. What's the average resident available hours? What's the maximum resident available hours? You see currently there's a big split. There's some resident which just due to probability hasn't used a lot of their hours currently. And the chart at the bottom, we're trying to infer how many apartments can we service with a single Tesla. So here in the beginning of the model, it's about 9 apartments per Tesla for this specific simulation. Okay. Then as we had our planned financials in the beginning, we also have our actual financials where we're comparing, why is it not updating? Okay, sorry. So the actual financial performance, we're comparing against the plan. We've got, thanks to our custom material design library, for those of you that have used it, we've got our own Gantt chart, which you're able to zoom in and out, pan left and right, and see a detailed Gantt chart of every single Tesla, whether they were busy charging, busy driving. We've got the same for all the residents. You can see when they were waiting, when they were driving, when was it weekend, not weekend, etc. We also have a nice 2D animation. And thanks to that tutorial from Ben on how to create the 3D, we even have a 3D version of this. And you can see the garage and all the Teslas there and moving around, being charged, etc., and changing color. On this front page, we've got our histograms, which shows you the statistics for every resident by type, apartment type, day of week, how much time is available, etc. And now we've got to the point where we chat with our GPT assistant. So here, very easily, I'm just asking it, please interpret the current results. Gives me a nice brief summary. I'm asking it what parameter is the model most sensitive to, right? And as a good GPT assistant, it's telling me I must do a sensitivity analysis, make gradual changes in order to figure out what parameter is it most sensitive to. So now let's go to our sensitivity analysis. I'm changing the free to use Teslas from 40 to 50 and pay to use as well in steps of 2. So not a very big experiment that we're going to be running now, only 36. So the model automatically sets them up, run as many as it can in parallel based on your CPU cores available. You're able to download a summary of the results, as well as detailed results of every Tesla and every action that they took with a timestamp. If we just take the summary results here for this specific scenario, we can draw up a little pivot table. We can put in our number of pre-Teslas and then the paid Teslas, show the waiting time, and try and figure out what's the threshold for achieving less than 5 minutes of maximum waiting time. And so for this scenario, we could see it was like 46 free Teslas and you've got 0 waiting time. You're having this GPT assistant as a standalone model object. I even put it into our sensitivity analysis. You can see here it provides a little bit more detail. It's saying that as your number of Teslas increase, the number of overflow Teslas, so that's that paid Teslas, increase, and it leads to higher cost. So we're asking, okay, what other experiments should we be running? So I was able to provide it that entire table that was in the Excel file as an input to the ChatGPT assistant. I'm asking what other experiments should I run. Sometimes it takes a bit of time for it to get back with the answer. It's saying we should adjust the pricing models. We should do different allocation and expiration policies. So it knows a lot about the model because we prompted. Now, as you can see here, the formatting is not that great. And to work on this formatting in AnyLogic on the UI is going to be quite a bit of work. So using ChatGPT, we built a very easy downloadable PDF creator. And if you download this PDF, it is as nicely formatted as it is when you do normal conversations with ChatGPT. And so now the user can keep this, right? And refer to it afterwards in terms of what it wanted to ask ChatGPT, what was the suggestions, etc. Else that chat is lost forever if you just have it that one instance in the model. Okay, Alan.
Thank you, Jacoben. As Jacoben showed in the model, this was really exciting to us. It was an exciting experience every time that we were running the model, especially in front of the team from Z-Life, to see whether the assumptions that we had originally was actually valid. And to our amazement, it showed that actually you can reduce the typical transportation cost for a resident, which is around $500 if you add up the lease or financing payment with insurance for a typical car, down to about $200. And that means that they would really get exactly the same experience as if they had their own car. There would always be a Tesla available, whether it's a free-to-use Tesla where they can use their 3 minutes, or a pay-to-use Tesla where they can rent it for a fraction of the normal cost. So that's a substantial reduction. That's another, $300 that you can put into the pocket of a middle-class family or young couple. We found out with experimentation that rather than the 50, then that what the sort of gut feel reaction was initially, that we only needed about 35 free Teslas. Obviously, it depends on the parameters that you've set up, and that you can start approaching a break even for the developers when you add in about 20 paid to use Teslas. Obviously, that is dependent on the level of utilization that you can get from the external side, etc. And the biggest benefit for the developer and the city is, of course, the reduction in parking bays. So the typical rule is if you're building an apartment building with 250 apartments, the developer has to provide at least one parking bay per apartment, so 250. And what we showed is that by benefiting from this aggregation, where essentially residents gets access to an asset rather than owning the asset, you can reduce the number of parking bays that's required from about 250 down to about 105. In terms of the future rollout, this is for the first apartment building that Z-Life is going to be building in Las Vegas. But we've created a model with an architecture that it's relatively simple to expand it for different types of apartment buildings, even for boutique hotels, to provide these type of answers to questions. And the developer and the media that so far has become aware of this project are super excited because it shows you what's possible with some innovative thinking. It's been an absolutely privilege to be part of this project, and a big thank you to my team that also incorporated the ChatGPT side, which is going to be very important in the future. We have teams sitting there and they just want to ask the model questions and get good suggestions in terms of what scenarios to evaluate. So we'll end it up there and see if there are any questions that we could answer in the remaining few minutes.
Alan, here's a question I think you can answer, or you can probably combine it. The question is, why Teslas? And then do we consider the possibility of Teslas being unavailable due to failures and unpredictable breakdowns, etc.?
Yes, why Teslas is, first of all, the owner is very passionate. She drives a Tesla herself. We actually reached out to Tesla. They got very excited about the project. They offered some very good sharing of data, and also provided some incentives if we moved ahead with this. And what's the second question? What's the follow-up question there?
Yeah, it's just in terms of the...
We did include the option to model, unavailability. So when they come back for inspection, there's an option there where if they either are dirty, they need to get a good wash, or if they pick up that there's some mechanical issue. The other thing is that the safety record and the quality record of Teslas is exceptional. They don't require maintenance often. So that was another reason for using the Tesla model. Yeah. Apart from the environmental impact.
The other questions was about the ChatGPT assistant, like why we created our own. And I think it's just because I quickly ran into the situation where we've got these big data sets that we want to give to ChatGPT. So give it the scenario object, right? So it's actually a JSON file that we put into a toString, so it's easy to interpret that, and give our material design library stuff to it. And then also I wanted to configure the ChatGPT so that when it gives, this is in the next phase. So when you ask it, what experiments should I run? It should know what experiments is possible, send back, oh, run experiment X, Y, and Z, change these parameters. And then the user can just say, oh, yes, I want to do that. And so ChatGPT actually controls the model, right? So we needed that sort of level of customizability and functionality that we wanted to add to it. So that's why I decided to, from the start, just do it a complete custom agent object. And we get to use this object now in other stuff like our HANA shop, the inventory digital twin that Ben demoed during the NVIDIA Omniverse presentation, or in any one of our other AnyLogic-based models. We can literally put it in and then give it our scenario object and so on, and then continue using it there.
I think that's it from our side. Thank you very much for the invitation from AnyLogic again to present this exciting model. And if there are additional questions or follow-ups, anybody have some suggestions on how we can maybe improve it or expand it to other areas, you're welcome to email us at the email addresses below. Thank you very much again.